pleasure and privilege to welcome you to the IEEE International Conference on Emerging Trends in Information, Communication and Systems, hosted by Bansal Institute of Science and Technology, Bhopal, and technically sponsored by the IEEE Madhya Pradesh section. This conference serves as a dynamic platform that brings together experts from academia, research and industry to exchange ideas, present innovative research and explore the latest advancement in information, communication and systems. We hope today's deliberation inspire meaningful discussions, foster collaborations and contribute towards technological advancement. Before we proceed further, I would like to request respected Dr. Sheetal Gupta ma'am, Associate Professor, CS Department, to kindly come forward and present serving to our esteemed keynote speaker, Professor Ranjit Mahantai sir, as a token of respect and gratitude. Please give a huge round of applause. Thank you so much, sir. We shall now begin the technical proceedings with our first keynote address. It's my privilege to introduce our distinguished keynote speaker, Professor Ranjit Mahantai sir. He is the professor in the Department of Electrical Engineering at IIT BHU with over 32 years of teaching and research experience. Professor Mahantai is a renowned expert in the field of power electronics. His remarkable contributions include numerous publications in prestigious IEEE journals, successful research projects, and the guidance of several PhD and MTech scholars. He has also served in several important academic and administrative roles at IIT BHU, reflecting his dedication to academic excellence and research. We are truly honored to have him with us today. I request everyone to join me in extending a warm welcome to Dr. Ranjit Mahantai sir as he delivers his keynote address. Please give a huge round of applause.
If the load is say is having diodes, they're having IGBTs, MOSFETs, thyristors, all these newer power electronic devices are there. in that case the load is a non-linear load. And why these devices are required? These devices are required to control the power in a better way. Okay? Now, in case of non-linear load, if the load is a non-linear load, in that case, the definition of power factor is that you can define the power factor like this. In case of non-linear load, the power factor is displacement power factor divided by I1 by IS. Okay? Now, what is the displacement power factor? Now, you see here in this waveform, the voltage is purely sinusoidal, the voltage is Vs is purely sinusoidal, where the input current Is is a perfect square wave. Okay? Now, let me tell you, in case of nonlinear load, the current is not sinusoidal. The current is either quasi-sine wave or quasi-square wave, depending upon the load conditions. Now, in this case, you see that I have assumed that the current is a perfect square wave and the voltage is a sine wave. Now, in this case, how will you define the power factor? The earlier definition of power factor that we have studied, that it is the cosine of the angle by which the current is lagging or leading the voltage, is not valid here, because in that case current was also sinusoidal, the voltage was also sinusoidal. But in this case, the current is not sinusoidal. Okay? So define the power factor. First of all, you will have to find out the fundamental component of the current. Okay? By the Fourier series. Okay? If you expand it, you will have fundamental component, third harmonic component, fifth harmonic component, seventh harmonic component, like that. The odd harmonics will be there, the even harmonics will not be there. Why the even harmonics will not be there? That we can understand through the Fourier series expression of this waveform. Okay? Now you see here the fundamental component is shown by the dotted line. Okay? Now the definition of power factor will be the cosine, the displacement power factor. How do you define the displacement power factor? The displacement power factor is defined as it is the cosine of the angle by which the fundamental component of current is lagging or leading the voltage. Okay? So that is the displacement power factor multiplied by the fundamental component of current divided by the total current. Therefore, to have a good power factor in case of nonlinear load, you will have to improve the displacement power factor, as well as you will have to remove the distortion from the waveform. Okay? So that is the basic idea of improving the power factor in case of nonlinear load. Whereas if it is a linear load, in that case you will have to take care of the displacement power factor only, because in that case the current is a purely sinusoidal waveform. Okay? Now, this is helping. Madam, how much is the time allotted? Huh?
30 minutes.
30 minutes, okay. Accordingly, I will wait. Okay? Yes, thank you. Okay? So, in case, so you will have to remove the distortion from the waveform, and also you will have to improve the power factor. Okay? Now, the conventional methods of power factor is reactive power compensation and harmonic filtering. Okay? Now, for reactive power compensation, the standard methods are thyristor switch capacitor, thyristor control inductor, and PWM static power compensator, or which is also known as instantaneous reactive power compensator with minimum energy storage element. Okay, so these are the conventional methods of reactive power compensation. Okay, now what is a thyristor switch capacitor? In case of thyristor switch capacitor, depending upon the requirement, the capacitors are switched one by one. Okay? First capacitor C1 will be switched on, then capacitor Cu will be switched on, and depending upon the requirement, the capacitors are switched on one by one. Now suppose there is a case that your power factor is close to unity, it is about 0.95 or 0.9, okay, and you have switched the nth capacitor. So in that case, what will happen? If the compensation is more than the required compensation, okay, in that case, the power factor will be leading. And what will happen if the power factor is leading? What is the disadvantage of having a leading power factor? In practical system, you never have leading power factor. Always you will have lagging power factor. In case of leading power factor, what will happen? The voltage will boost up. Suppose from the supply end, you have sent a voltage of 230 volt or 220 volt. Now, if the capacitor size is more than the required size, in that case, the power factor, your voltage will be 240 volt or 250 volt, which is not required. Okay. Now, in that case, you will have to reduce the value of capacitor in such a way that the power factor is not leading. Okay. Now, how will you nullify the effect of the capacitor? By placing an inductor. Okay. So, wherever you have a thyristor switched capacitor, okay, you need to have a controlled inductor also. Now, the thyristor switched capacitors gives you fixed value of capacitance. Okay. Whereas this controlled inductor gives you controlled value of inductance. Okay. So, this is the circuit of that. Okay. So, here you can see that as we are changing the value of alpha from 90 degree to say 120 degree or 135 degree, the fundamental component of the current which is flowing through the inductor is continuously changing. Okay. Therefore, by changing this inductance value, you can nullify the additional capacitance value which has come into picture. Okay. So, you need to have a circuit like this where you have a fixed capacitor, and with fixed capacitor you have a controlled inductor also. Okay. Now in this case, from the expression you can say that the leading power factor was supplied by the system is given by Vs square divided by 1 by omega c, and the lagging power supplied is Vs into IL1. Okay. So from these two expressions we get the net watt supply, and the net watt supply should be equal to the reactive power demand of the line, which is equal to Vs Is into cos phi. And if you equate these two equations, you will get an expression Is sin phi is equal to Vs multiplied by some expression. Okay. So in this case, what you have to do that you have to measure the value of Is sin phi. Okay. And once you will measure the value of Is sin phi, from the expression you will get the value of alpha, and accordingly you will have to choose the value of alpha so that the power factor is close to unity. Okay. So this is your conventional method of reactive power compensation using thyristor switched capacitor and thyristor controlled inductor. Okay. Now, this conventional methods of thyristor switched capacitor and thyristor controlled inductor is that as the watt generated or absorbed in these schemes are directly proportional to the energy storing capability of the capacitors and inductor. Okay, so the size of the capacitors and inductors becomes very, very bulky in case the reactive power to be supplied is large. Okay, and also this thyristor switched capacitors and thyristor control inductor schemes has a major disadvantage that they generate additional current harmonics into the system. So the case is that you are trying to improve one thing, that is this part you are trying to improve. First part was your this one. First part is your displacement power factor. You are trying to improve the displacement power factor, but at the same time you are deteriorating the ratio I1 by Is. Okay. Therefore, the additional harmonics generated in the system are to be eliminated. Okay. So how those harmonics will be eliminated? The conventional method of doing that is to use shunt passive filters. Okay.
conventional method is to use a shunt passive filters. Okay, harmonic filter, shunt passive filter. Shunt passive filter is nothing but a combination of L and C tuned at a dominant harmonic frequency. Okay, the harmonic current flows through them and the harmonics are eliminated from the system. The conventional shunt passive filters has certain demerits, like for filtering several harmonics, you require different shunt passive filter tuned at different frequencies. The other disadvantage is that the source inductance strongly influences the compensation characteristics of passive filters. Okay, even if you have tuned the filter at the third harmonic frequency, because of this effect of the source inductance and because of the effect of other filters, they seem to be detuned. Okay, so it is very difficult to tune the shunt passive filters at the appropriate frequency. That is, if you are tuning it at 150 Hz, okay, it will be automatically detuned to 145 Hz. If you have tuned it to 250 Hz, it will be automatically detuned to 240 Hz. So that is the main demerit of the shunt passive filters. Now, one more method is that there, which is known as PWM static war compensator. Now, what is a PWM static war compensator? PWM static war compensator is nothing but a voltage source inverter. Okay, where the DC side is a pre-charged capacitor. Instead of having a DC source, we have a pre-charged capacitor. Now, depending upon the requirement, we can generate a compensation voltage V compensation 1. If the V compensation 1 is greater than the supply voltage, leading current with respect to supply voltage will be drawn by the inverter and supplies lagging power to the system. That means it will behave as a capacitor. If V compensation 1 is less than the supply voltage, okay, V compensation 1 is the fundamental component of the voltage generated at the output of the inverter. If V compensation 1 is less than the supply voltage, the inverter draws lagging current and it supplies leading watts to the system. Okay, and apart from that, the voltage output of the converter is not a pure sine wave. Okay, it is a quasi sine wave or quasi square wave depending upon the firing angles. Therefore, you can supply the fundamental component of current through that. That means you can improve the displacement power factor, and also you can supply the harmonic currents to the system so that the harmonics are eliminated from the supply. Okay, so voltage source inverter is a standard method for improving the power factor of the system, for improving the displacement power factor, as well as for improving the ratio of I1 by IS. So these are all about the standard methods of reactive power compensation and harmonic filtering. Now I will tell you some new method which first time I proposed some 20 years back that I did using a large value of AC capacitor. Okay, and what is the problem in realizing a large value of AC capacitor? So let me tell you that large value of AC capacitor is not available in the market. Small values of AC capacitors are available. That means you will have AC capacitors of 50 microfarad. You can have AC capacitor of 100 microfarad, but you don't have a AC capacitor of 1000 microfarad or say 1500 microfarad or say 2000 microfarad. Whereas the DC capacitors are readily available in large amounts. Now, is it possible to realize an AC capacitor using DC capacitors? Okay, so let me tell you about the circuit of that. Large value AC capacitor. Now you see here in this circuit, there are two capacitors, C1 and C2, and there are two diodes, D1, D2, and there are two switches, S1 and S2. Okay, the supply voltage VC, the capacitor voltage VC and the capacitor current are shown here. Now, how we will realize an AC capacitor using two DC capacitors? Before that, let me tell you, if it is a DC capacitor, it can withstand only unipolar voltage. If a DC capacitor is rated for 500 volts, it can block a reverse voltage not more than 2 to 3 volts. If the reverse voltage is more to 2 to 3 volt, in that case the capacitor will be destroyed. Okay, that is the problem with the DC capacitor, because it is unipolar capacitor. Okay, now you see in this circuit what is happening. This is divided into 4 modes: mode 1, mode 2, mode 3 and mode 4. So in mode 1, what will happen? In mode 1, that is T0 to T1, during first quarter voltage cycle, the current flows through C1 and D1. That means the current is flowing through C1 and D1 here. Okay, and when it is flowing through C1 and D1, the capacitor C1 charges to the peak supply voltage at the end of interval T1. That means at the end of this interval T1, the capacitor is charged to peak of the supply voltage. Which capacitor? The capacitor C1. Okay, now it has charged. Now what will happen? You need to discharge it also. Okay, so how will you discharge it? One more thing is that, let me tell you that when C1 and D1 are conducting, some reverse voltage appears across capacitor C2, and that is the reverse voltage. What is the forward voltage drop of the diode? It is 1 to 2 volt, not more than 1 to 2 volt. And already I have told you that the DC capacitor can withstand a reverse voltage of the order of 2 to 3. So if a voltage of say 1 volt appears in the reverse direction across the DC capacitor C2, it will not damage capacitor C2. Okay. Now capacitor is charged to peak of the supply voltage at the end of the interval T1. Now you have to discharge this capacitor. So how will you discharge it? So the switch S1 starts conducting at the beginning of this interval. Okay, so what will happen? That you turn on the switch S1. Switch S1 is an IGBT switch. So when you will turn the switch S1, the capacitor C1 starts discharging through the switch at the source. And at the end of the interval, the capacitor C1 will be fully discharged. Okay, so this is about the positive half cycle. Initially, in mode 1, C1 and D1 are conducting. At the end of this interval, that is at the end of T1, the capacitor C1 is charged to maximum of the supply voltage. Then in mode 2, you are turning on switch S1. By turning on switch S1, you are discharging the capacitor C1, and at the end of this mode, the capacitor C1 is completely discharged. Okay. Similarly, in the negative half cycle, what happens? Capacitor C2 and D2 are conducting. Okay, and at the end of this interval, that is at the end of mode 3, the capacitor C2 is charged to maximum of the negative supply voltage. Okay, at the end of interval mode 3, that is at the end of, that is at T3. Okay, so what you have to do is that at the start of mode 4, you have to turn on the switch S2, and when you turn on the switch S2, okay, what will happen? The capacitor C2 starts discharging through that, and at the end of mode 4, the capacitor C2 is completely discharged. So in this way, using two DC capacitors, two diodes and two switches, you can realize a large volume of DC capacitor. Okay, so if we use electrolytic capacitors are available in large, say 1000 microfarad, 1500 microfarad, like that. Okay, you can realize a large value of DC capacitor. Okay, so yes, now new quasi-passive filter scheme was proposed. Now in this scheme you can see large value of capacitor C is denoted as C. Okay. Now, if you use this for in a circuit, what will happen? If a large value of AC capacitor is connected in a circuit, so 1 by omega C is what happens? It's very, very small. Okay, larger the value of C, lesser the value of the reactance. So it will behave like a short circuit, is it not? If you connect a large value of AC capacitor to a supply, so it will behave like a short circuit. So in that case, you will spoil your system. So what is done here is that there's a parallel resonant circuit, combination of C and L1. So that is tuned at the fundamental frequency. If that is tuned at the fundamental frequency, it will not allow the fundamental component of current to pass through it. Although very small component of fundamental current may flee through that, because the capacitor is also some resistance. The inductor has also some resistance. You cannot make it fully resistance zero. Practically it is not possible, theoretically it is possible. But the fundamental component of current that will flow is very, very small. Okay? And if C and L2 is tuned at the dominant harmonic frequency, I can show you that if the value of the capacitor is very, very large in shunt passive filters, all the harmonic components flow to that. Okay? And with one set of shunt passive filter tuned at the lowest harmonic frequency, you can filter all harmonic components. Okay? Now for that, I can show you some expression. This is the impedance of the circuit. If L1C is equal to 1 by omega naught square, in that case, the impedance of this circuit for the fundamental component is infinite. And if the impedance is infinite for the fundamental component, theoretically, with no resistance assumed. Okay? So in that case, no fundamental component of current is allowed to flow through that. And for ZF, Z and omega naught is equal to 0, that means for the harmonic frequency, it is providing zero impedance. That means very good filtering effect. Okay. Now, I will show you a Bode plot here. Okay. In this Bode plot, I have assumed different values of capacitances. Okay. And plot number 8 is the frequency response plot of source impedance, where the value of Ls is assumed to be 2.5 millihenry and value of Rs is equal to 0.2 ohm. Okay. Now you can see in phases 1 to 3. Okay. In phase 1, the capacitance value is taken as 1000 microfarad, and according to the value of L2 has become your 1.27 millihenry. Okay. If you increase the value of capacitance to say 1500 microfarad, the value of L2 becomes equal to 0.84 millihenry. And if you take the value of capacitance equal to 2000 microfarad, in that case, the value of L2 is equal to 0.63 millihenry respectively. Okay. In that case, the QPF is tuned at the third harmonic frequency. Okay. Now you can see here the larger value of capacitance you take, okay, the gap between the shunt passive filter and the source impedance is getting larger. That means it is providing you better filtering effect. Okay, and I have also shown a curve here that if the shunt passive filter is tuned at the fifth harmonic frequency and there is a normal shunt passive filter tuned at the third harmonic frequency, in that case you will get 4, 5 and 6. So the filtering effect is even better than that. Okay, so it can be explained with the help of some simulation circuit also, that this has been simulated using PSpice. Here the load is taken as diode rectifier feeding RC load. Okay, if so, in that case you can see that I can show you some of the results that see IRL is completely distorted. Okay, IRL is the current, load current. Okay, if you try to find out the THD of this, the THD will be of the order of 80% or more than 80%. Practically THD is not that high. Practically THD value is about maximum is go up to 12% or 13% like that. But here we have taken the worst case, that is THD of about 80%. Even then you can say that Once we have connected the shunt passive filter, the current has become sinusoidal. Okay, almost sinusoidal. And you can see that IL2, the current passing through the shunt passive filter, it is IL2, it has very little, the last one, it is very little fundamental component. And it can be explained with the help of, you can see that the harmonic spectrum, ILL, you can see that lot of harmonics are there, whereas in the ILS, the source current, no harmonics is there, and also in the voltage V2, voltage at the common point of coupling, it is distortion free. IL1 is also sinusoidal, and IL2, the current which is flowing through the filter, contains very little fundamental component of current, and it has all the harmonic currents present there. That is, it has third harmonic current, it has fifth harmonic current, it has seventh harmonic current, like that. Okay. Now I have done it for RL load also. Okay. RL load, the distortion is not that high. For RL load, if you make the value of inductance infinite, the distortion will be about 48%. Okay, TSD will be about 48%. So for RL load also, I've drawn it. Okay, in RL load, the load current is almost a square wave. Okay, whereas you see that after connecting the shunt passive filter, the current has become almost sinusoidal. Okay. Now, I have taken a table, typical harmonics in a single phase input current with no line filtering. This table has been taken from the Nedmohan's book. Okay, so here the third harmonic is 73.2%. The fifth harmonic is 36.6%. The seventh harmonic is 8.1%, like that. So we have taken a worst case. Okay. Now, if for the worst case, you see, in one case, we have taken the capacitance C1 and C2 is equal to, say, 1500 microfarad. So in that case, the TSD is around 7.1%. Okay, the current TSD, and the voltage TSD is about 5.24%. If you increase the value of C1 and C2 to, say, 2000 microfarad, okay, you see the value of current TSD and voltage TSD have reduced. If you further increase the value of C1 and C2 to, say, 2500 microfarad, the value of current TSD and voltage TSD are further decreasing. Okay, and if you have an additional shunt passive filter tuned at the third harmonic frequency, and the QPF is tuned at the fifth harmonic frequency, which C1 and C2 are equal to 500 microfarad, you see the value of TSD is equal to, current TSD is equal to 4.4%, and the voltage TSD is equal to 2.48%. That means if you have a very large value of capacitance with one set of shunt passive filter tuned at the dominant harmonic frequency, you can eliminate all the harmonic components. You don't require large number of shunt passive filter tuned at different harmonic frequency. Neither you require active power filters. Okay, because there the control is very, very difficult, and here we don't require any control. Okay, without using any control, you can eliminate all the harmonics. Now, what about the reactive power compensation? We have eliminated the harmonic components, but at the same time, you will have to improve the displacement power factor also. Okay, time is over. Another 5 minutes just. Okay, so in this case, the modified static power compensator, that means we have little bit modified the circuit. Okay, and in this case, it is not tuned at the fundamental component, it is slightly detuned. Okay, so in that case, it can take care of the harmonic components as well as the displacement power factor. Okay, now the relevant expression, I can show you that this is the relevant expression, that equation number 10. Using this equation number 10, you will have to take care of the reactive currents, and the harmonic currents will be taken care of by the passive filter. Okay, so using a large value of AC, you can see the simulation circuit also. This is the simulation circuit, and using this you can improve the displacement power factor, as well as you can remove the distortion from the system. Okay, so this is the thing. and this was experimentally also verified. And these papers in those time, in some 20 years back, I published one paper in large value AC capacitor for harmonic filtering and reactive power compensation that was published in IIT Generation Transmission and Distribution. One paper I published in was the passive filter for harmonic filtering in electric power system research. That is also a power system journal, Elsevier journal. Then one paper I published in International Journal of Circuit Theory and Applications, that is a Wiley journal. And then one paper I published in Electric Power System Research, that is also a Elsevier journal. Okay, so this is the conclusion. Okay, so any questions from your side?
What is the purpose of using two different inductors in reactive compensating power? If you use two different inductors, L1 and L2.
Just let me tell you, this is the circuit. Okay, this is the circuit. This one, okay, this circuit, no?
No,
The L1 and L2. Okay.
this.
Now, what happens here? C1 and L2, they are tuned at the dominant harmonic frequency, at suppose third harmonic frequency, at 150. So, this will eliminate all harmonics. And then, this L1 is used along with the capacitor C for reactive power compensation. If there is any overcompensation, okay, this L will take care of that. And again, this C and L2, they along with L1 are tuned near to the fundamental component, not exactly at the fundamental. So that is the purpose of two inductors. One inductor for taking care of the harmonic components and other inductor for taking care of the reactive components. Any more questions?
So that is actually the physical phenomena behind if you increase the value of capacitors
But
actual physical phenomena.
But the difficulty is that there are so many difficulties because there is a large current flowing in the circuit.
Yes.
Because if the capacitor is very large, so to handle those large current, you require very, very high rated devices. Okay, those devices are there. And you cannot make the capacitors resistors free. Okay?
Yes.
Because the electrolytic capacitor has substantial value of ESR, equivalency resistance. So those problems are there. So when you will do one good thing, so many other things are associated with that. Suppose COVID injection was for getting rid of COVID, but it has side effects also, and the side effects are not less. Okay, so advantage and disadvantage are associated. You have some advantage, you have to have some disadvantage associated with that also. Okay, so thank you then.
Thank you so much, Professor Mahante sir, for your enlightening and inspiring keynote address. Your valuable insights have enriched all of us all and will certainly inspire future research and innovation.
चावला जी को लेने कोई सोचा था वो दैट इज अ अपॉर्चुनिटी चावला से को लेने किसी को भेजना पड़ेगा
And gratitude. Please give a huge round of applause.
जी सर, हाँ सर।
To please come forward and deliver a vote of thanks. Thank you, Jessica. So first of all, very good afternoon to all. I would like to firstly thank you, our respected sir, for this wonderful keynote session. Dr. Ranjit Mohanty sir, professor from IIT BHU, and it was really wonderful session, sir. Then I would like to thank you, IEEE MP section, for funding this conference. I would like to all participants, those who are present here, and I give my gratitude towards the management of BGI to give the opportunity and this platform to conduct this IEEE conference. So thank you so much all the participants for listening patiently for these wonderful keynote sessions. So thank you all once again. Now we'll proceed for the technical session paper presentation. So participants, be ready for that. We have the session chair with us. Thank you. Session chair, please enjoy. तो डायरेक्ट उसमें ही कर देंगे ना, उसी में
BIST Bhopal student.
Hello everyone. We shall now commence technical session which will feature research presentations on emerging advancement in artificial intelligence, machine learning, healthcare technologies, cybersecurity, and next generation communication systems. To preside over this technical session, we are privileged to have two eminent academicians as our session chairs. Before we proceed further, I would like to request our respected Professor Sana Khan ma'am to kindly come forward and present a sapling to our esteemed session chair, Professor M.P.S. Chabla sir, as a token of gratitude and respect. Please give a huge round of applause. Now, I request our respected Professor Twinkle Sharma ma'am to kindly present a sapling to our esteemed session chair, Dr. Sandeep Sahu sir, as a token of respect and gratitude. Thank you so much, sir. With this thoughtful gesture of appreciation, it's now my honor to introduce our esteemed session chairs. It is my honor to introduce Professor M.P.S. Chabla sir, Associate Professor in the Department of Electrical Engineering at Sri Govindram Seksari Institute of Technology and Science, Indore. With over 36 years of teaching experience and extensive contributions to research, Professor Chabla specializes in power electronics, signal processing, image processing, intelligent instrumentation, soft computing, and smart grid systems. He has published more than 130 research papers, reviewed numerous international journal articles, and currently serves as the Secretary of IEEE Madhya Pradesh section. His remarkable dedication to academics, research, and professional service has earned him recognition both nationally and internationally. We are truly honored to have him as the chair of this technical session. Please give a huge round of applause. It is also my pleasure to introduce Dr. Sandeep Sahu sir as Associate Professor in the Department of Computer Science Engineering at Lakshmi Narayan College of Technology, Bhopal. He completed his BE from Sati Vidisha, his MTech from IIT Guwahati, and is currently pursuing his PhD in Computer Science and Engineering from Rajiv Gandhi Pradyogiki Vishwavidyalaya. His research interests include wireless sensor networks, mobile ADHOC networks, healthcare systems, and the Internet of Things. We are delighted to have him as the session chair for this session. Please give a huge round of applause. May I request everyone to Now, before we begin the paper presentations, I would like to share a few important guidelines with all the presenters. Each presenter will have total of 15 minutes. 10 minutes are allotted for the presentation. The remaining 5 minutes are reserved for the question and answer round. A gentle reminder will be given after 8 minutes to help presenters manage their time effectively. All presenters are kindly requested to adhere to the allotted time to ensure the smooth conduct of the session. The Best Paper Award will be presented based on the evaluation by the session chairs. The evaluation will be based on the following criteria: rationale of the study, literature review, methodology, presentation clarity and organization, handling of the question and answer session. We wish all the presenters the very best. With that, let us now begin the paper presentation session. Our first presenter is Ms. Prashali Vilore. Her paper is titled Deep Learning Based Detection of Real and AI Generated Images with Multiple Generators and Multiscaling Features. May I request Ms. Prashali Vilore to kindly come forward and begin her presentation.
रिमोट मैडम को रिमोट देना मैडम को रिमोट
Am I audible? Good afternoon. Good afternoon to the respected session judges and my fellow participants. Am I not audible? Good afternoon. Am I audible now?
Yes, I'm audible.
Yes. Good afternoon to the respected session judges and every distinguished guest and my fellow participants, everyone present here in this prestigious conference hall. I am Rashali Billore, working as an assistant professor in Allen City, Lakshmanaran College of Technology and Excellence, Bhopal. Here I am presenting the research work with the title Deep Learning Based Detection of Real and AI Generated Images with multiple generator and multi-scaling features. These are the outlines of the paperwork. Presently, there are so many image generators, seen and unseen, and they can be computer based or AI based, as we can see. There are so many detection methods are also there, and these detection methods detect and classify all the images which are fake, deepfake images. So the fake images are having negative impacts on the society, like massive misinformation, identity theft, and fraud, financial fraud, etc. This very proposed paper addresses the problem of real and fake image detection and also perform better than the previous or existing papers which have already worked in AI generated detection methods. Why this paper is better? Because the existing detection methods show poor performance and on unseen generators and new deepfake techniques. It is still a challenging task to detect highly realistic synthetic images and artifacts. So, to address the need for generalized and robust framework to accurately distinguish real and AI generated images, this proposed paper was made. To overcome the limitations of existing detection methods, this paper proposes two methods for detecting and distinguishing real and AI generated images. First is EWEF-NET and second is XSA-UNIT. Both are deep learning models based on CNN, convolutional neural network, attention mechanism, and multi-scale feature extraction.
Madam, sorry to interrupt, you should not read line by line. Be in touch with your slides and talk to the audience. That is the way of presentation of paper.
Actually,
Otherwise, you are reading for each and every line, so how you communicate with the audience?
yes, sir, I'm sorry for that. This is my first ever presentation.
It's okay.
I'm really nervous.
No, you should not be nervous. We are part of you, we will help you.
Yes.
But you should not line by line.
It belongs to you, this work.
Yes, yes.
So you try to summarize what you have done.
Actually, I've written in my language in the paper so that I can simplify.
So if you have understood what you have done,
Just
you will explain it. Then in case if we ask some queries to you, then you can say, sir, please refer to the following slide. That is the way of presentation.
Wherever you're confident with your work, wherever you contributed, just show it.
You know from where you started, you know the conclusion of the paper.
Yes.
In between, what are the simulation results you have obtained? What methods you have used? Speak in your words. Beta, don't hesitate. कहीं ना कहीं आपको you should give up your afraidness. ठीक है बेटा? Try. कुछ नहीं है ना? We will appreciate if you do extempore for the first time. ठीक है? Marks अच्छे ही मिलेंगे आपको. Don't worry. We want that you should be interactive.
Yes. Sorry, sir. First.
It's okay. Well, it's my suggestion. It's up to you. आप पढ़ के भी सुनाएंगे तो सुनाएंगे.
Your kindness, yes.
Please.
This was the abstract, and we have included the result of XSA unit. Why? Because we have incorporated two methods, but the XSA unit gives better result in classification, and EWFNet gives better result in detection. So in introduction, we have again explained why the existing papers were poor in generalization and existing detection methods, and there were failure in generalization, artifacts detection, and why this new paper was proposed, because we were incorporating the more generalized form methods and multi-scaling features, etc. In the literature review, there are before methods like datasets like GAN generated images, deepfake dataset. These were poor performance and giving less accuracy, and the new dataset which were incorporated in the paper, in the proposed paper, which were AI generated dataset and the computer produced dataset. Both were giving more accuracy, and as you can see, and the research gaps were still the same as we have discussed earlier: poor cross-generator performance and generalization issue, and there were overfitting issues. All of those issues, and these were identified in the proposed paper, and these proposed paper has tried to resolve those earlier problems.
Come to your proposal. Yeah, whatever you have done.
Yes.
Come to your problem formulation.
Yeah.
Yes, these are the methodology. Like I have said, there are two data sets which have been downloaded from Kaggle, the free data set, and these data sets are AI generated and computer based data sets. And we have two methods which are working on detecting and classification. So both the methods are doing the things like multi-level detection and classification, solving overfitting problem, generalization, multiple classification, fine artifact detection, and so on. And how the workflow is happening is first the data is collected, and it is then converted into vectors in feature engineering. Then the data set, when converted into vectors, it is giving to the model. Model is trained on those data sets, and then the detection and classification happens.
Which model you use? Like you will use deep learning models.
Yes.
Which model you adopted for your work?
So both the models we have used, like optimal attention combination, which is EWFNet, and exception filtered UNet framework. Both the models are used. But first, the EWFNet is used for detection, and the second is used for classification.
Because you have done the problem of pattern recognition.
Yes.
Pattern recognition.
Yes.
That's why it is necessarily to classify
Yes.
in the secondary stage.
Sir, detection is not enough. So
Yeah, yeah.
classification
In the
has
secondary
to be
stage.
there.
In the secondary stage.
Yes. Yes. So as the accuracy, as we discussed the result and accuracy, the EVFNet gives 97.8% and XSANet gives 98.39% accuracy. And the conclusion is that the proposed work has resolved the overfitting generalization and cross-generator problems. So it can both the proposed models can be incorporated in building applications and real-world image detection and classification problems. Thank you so much.
Before conclusion, it was a nice presentation. Since it is an image processing paper, you have not shown a single image to us.
I've taken a data set like you have pictures.
You have concluded accuracy, etc. You did not show even a single image result. How can you conclude it? Which image you have taken? Right? Removal of artifacts, noise, isn't it?
Yes.
You might have done cropping also.
Yes.
So you have not shown a single image.
Yes, I had.
Did you did in the paper?
Yes.
Results in the paper.
Yes.
You have the copy of that PDF right now.
You have a copy of paper. The paper का copy है.
Yes.
उसमें है mention images सब कुछ.
तो PDF दिखा दे.
Images नहीं है सर उसमें.
ठीक. Thank you.
Thank you. Thank you.
थोड़ा confidence बढ़ा. Next step और.
Thank you so much, ma'am, for your presentation. Now I would like to invite Ms. Vinita Srivastava. The title of her paper is Integrated PCA Driven Augmentation and Resider Unit with Loss-Aware Feature Exchange for Brain Tumor Detection.
Paper IDs.
400 बनाई. 400. Yes.
Am I audible? Okay. So, good afternoon, respected session chairs, co-chairs, and everyone present. I am Dr. Vinita Srivastava, and today I am going to present our proposed deep learning framework, which contains accurate detection of MRI images and brain tumor detection. Okay. So, my topic is related to brain tumor detection using the MRI images. So, moving to these are the outlines of my presentation. Now moving to the abstract, as we know that brain tumor is very critical brain disorder and timely detection is very much efficient for the successful treatment. But the problem is that the already existing works require the manual segmentation of images is very difficult and it requires the radiological expertise to detect the images whether it is a contained tumor or not. So this is not only possible with the help of the traditional machine learning or deep learning based algorithm. We need some advanced solution for this. So this research comes with the solution to detect the most tumor segmentation images that is based on the MRI images. So this work uses the Bradshaw 2019, 2020 and 2021 data set for brain tumor detection, and it also uses the performance metrics like the DICE score and intersection over the union for the proper segmentation of brain disease disorders. Now moving on to the introduction, the major challenges in brain tumor detection is basically the traditional machine learning algorithms are not enough, and it requires the poor generalization, or it requires the high training data sets, and the main reason, the main limitation is class imbalance. So this research came with the solution. This research is based on deep learning approach, which consists of PCA based analysis for the class imbalance. We use PCA analysis in this work because it is based on the dimension reduction problem and solves the solution of the class imbalance. Next in this work, UNAT model is used. Basically, residual UNAT model is used, which is used for the block segmentation of the brain disease orders, and it is implemented or it is integrated with information exchange gateway. So it is a hybrid model using information exchange gateway with residual UNAT. And these are the existing work. Previous work on the brain tumor detection uses the model like local MRI images, or it uses the convolution neural network, transfer learning, and many other models. But these models come with the good accuracy. But also these models have some limitation like poor generalization or class imbalance issue, and also some models have the high computational cost. This research work overcome with this solution and find out the three research gaps. The first research gap is as existing model do not generalize on different Bratis data set which is downloaded from Kaggle. We used over 3 years Bratis data set 2019, 20 and 21. So the existing model or the existing work do not generalize on all three types of Bratis data sets. The second limitation or the second research gap we have found that small brain segmentation are not completely identified or are not accurately identified with existing models due to heavy class imbalance issue in these data sets. So previous work do not accurately identify the class imbalance, and they do not segment the brain tumor segmentation reason. And the third research gap we had found with the existing work is traditional UNAT model. Only UNAT model do not 100% or do not mostly classify the images. The reason is that only UNAT is not sufficient. So this work is integrated with residual UNAT model with hybridization of information exchange gateway. The work of information exchange gateway is to send the information between the encoder and decoder. So the main objective of this work is to first accurately identify the brain lesion segmentation. The second objective is to balance the class imbalancing issue. For that we have used the principal component analysis, and the third objective is to check our model with accurate performance metrics like the accuracy, DICE score and information over union. So this is the proposed methodology of our work. First, we have collected the data from the Kaggle, that is the BRATSET 2019, 20 and 21. Each per year data set contains 300, more than 300 subjects, and one subject has the one patient, and one patient may have images more than 1000. So over the whole three images were 2 lakh, approx 2 lakh thousand. Out of which then pre-processing is applied. For that Z-score indexing is used for identifying the pixel intensity. After that data is divided into 70% for training and 30% for testing. Next PCA based data augmentation is used. PCA data augmentation is used for better class imbalance, to solve the problem of class imbalance, and also accurately classify the model on unseen data set. Next, the proposed model, that is IEG, Information Exchange Gateway Residual Unit model is used. This the work of the IEG, Information Exchange Gateway, is to better exchange the feature, or in better way it exchange the feature between the encoder and decoder, so that the maximum feature of that image are identified. After that, loss aware exchange is used. Further work of the loss awareness exchange is to better identify the union section and the dice score. Dice score refers to the accurate measurement between the predicted and output image, so that the main reason this work not only identify that patient image, MRI image has brain tumor or not, but it also classify the percentage, how much the segmented image is identified as per the classification for that particular image. Then at last, the performance evaluation like the dice score, accuracy, and IUC are used for the performance metrics. So these are the image, these are the basically architecture which I used in the proposed work. Basically, I also explained in the previous slide. This slide is the theoretical, and this is the basically image. The images are used at the T1, T2, and T3. These images are downloaded from the Kaggle from the Bansal data set. T1 means the Tesla. Tesla is the unit of that MRI image. Then these images are used for in the pre-processing, that the normalization. Then it goes for classification. Before classification, the proposed residual unit model is used, so that. Okay.
Please come to your results.
Now these are the results. The proposed model. The proposed model outperforms the existing work. With the PCA, it identifies the highest accuracy on the Bansal 2021, that is 99%. And without PCA, this is the during the PCA which identifies the better accuracy. And also the using PCA, not PCA, we can see the difference. It approx the classification accuracy is 99% with the highest dice score and information over unique model as compared to the existing work. Now this is the comparison with our proposed model. With table 4 compares the REST unit or without REST unit. It means information exchange gateway and residual unit. So WT stands for whole tumor, and combined tumor, and ET. And also the residual unit is not giving the better performance, and the information exchange gateway gives the better performance over ResNet unit model. Then table 5 shows the comparison with the previous work. Table 6 shows the dice score, which is proposed unit model gives the better accuracy, that is 99.1% on the whole tumor detection. Now, I would like to continue.
Again, a surprising question from my side.
Yes.
You did all image analysis and none of the images.
So basically, I just used in this for the pre-processing, not on as this is the conference paper, so I have not used the whole segmented image.
No, but did you submitted this in your research paper?
Images? No, not images. I just used these tables to summarize my paper.
Now, before conclusion, I want to ask you, you worked on PCA.
Yes.
And PCA is basically used for dimensionality reduction and removal of redundancy.
Yes.
Let me tell you, my 15 papers are on PCA ICA.
Okay.
In journals like elsewhere, Springer, Taylor Francis.
Okay.
So you can just refer my papers. My name is
Professor. So surely I will refer.
Professor M.T.S. Chawla.
Okay,
और बेटा आपने जो रिजल्ट्स दिखाए हैं, आपने ट्यूमर भी हटा दिया, डिटेक्ट भी कर दिया, तो हमें एक बार दिखा तो देते कि ट्यूमर है कहाँ?
So basically it is.
This is very surprising कि the tabular result shows everything is under your control, but image is missing.
Yes, I have to put some image that before the classification and the after the classification.
How it can be?
So in future I will take care of this.
You should take care in future presentations. Because how can you justify this table?
Okay.
And secondly, you have used Kaggle.
Yes.
Isn't it? Why did you not go for Google Colab?
Google Colab images
Have you
from
heard of
Google. Yes, I have heard, but
what is your basic knowledge and understanding of Google Colab? It is more user friendly. A good platform for AI building.
sir, yeah, although
To authenticate the Kaggle data set is already valid. Have you search any other data sources other than?
yeah, there are many data sources. Actually, we can prefer for clinical data set also.
That's why.
Okay, that when we will get the real images of patient.
You should have taken a real-time data from some hospital, healthcare system, and you would have said that this patient is suffering from this extent of leukemia.
That will be more accurate and more real image. Okay, sir. In future, I will take care about that.
And secondly, based on PCA, you did feature extraction.
Data augmentation and dimension reduction.
Dimension reduction. So, where you calculate the eigenvectors. Principal component analysis you have used, huh?
Yes, sir.
So PCA में the highest principal component contributes to maximum information.
Yes, sir.
And remaining all are diminishing. So at least you should go for 5 eigenvectors.
Okay, sir.
Okay.
Sir, thank you for your guidance. I will definitely prefer your papers.
They are around 30 pages.
Yeah, definitely I will go through that. It will be very fruitful for me.
Elsewhere, Springer and Telefrancis. उसमें आप देखिए कि काम कैसे करते हैं PCA पे.
और सेशन में होना चाहिए. If you are working on images like MRI, whatever. But एक रहता तो थोड़ा सा क्या इंटरेस्ट भी रहता है.
And actually, you know that image processing works on ROI, region of interest.
No, sir, I have not heard about
बस तो फिर कैसे हो गया? ROI region of interest means you want to find out the healthy portion as well as the infected portion.
Yes, yes.
So infected portion you enlarge it, do its analysis and
More segmented area.
Okay. So take this as advice for your future presentation.
Yes, sir, definitely.
Otherwise, you have put a hard work to do it, but authentication आपकी तरफ से missing है कि image ही नहीं है.
Okay.
और कोई image वाला तो नहीं है जो आगे हमको यही बताने वाला है. Please take care in your presentation. ठीक है?
So may I?
Yes.
Okay. So to conclude, the proposed model is used for the brain tumor detection. The information exchange gateway is gone for the information exchange from the encoder to decoder. And in the future, I will use the clinical data set. Okay, and these are the references which I have used for this work. Thank you.
Okay.
Good. Please take them care next time.
Thank you for your advice.
Now I would like to invite Mr. Anish Mahesh Sangha sir. The title of his paper is An Efficient Class-Weighted Machine Learning Approach for Early Stroke Detection.
Check. Good afternoon, respected judges. My name is Anish, and my work is an efficient class-weighted machine learning approach for early stroke detection.
You are student of
I am student of Universal College of Engineering, Mumbai. I am third year student, engineering student, and the paper ID is 1, and the paper ID is 404. Track number is 1. Now, when we go towards the abstract section, the keynotes of the research paper that we have published here, we have proposed an end-to-end framework where stroke can be detected early, in the early stage. Because stroke is something, a disease that can damage the brain permanently. So if it is detected in the early phase, there is a lot of scope that this can be, waved off or treated in a better way so that lives can be saved. since it is a global problem, and we have gone through a lot of research paper where we found out a few limitations where we tried to put in a gap or bridge between those limitations. So our stratified setup or the data of total patients here is 5,110. You might have thought like, why is the number very low? We are building something, or we have built something which believes over quality over the quantity. The readings that we have here, 94.7% as the accuracy, weighted F1 score and all that, it has come because we have preserved the integrity of the data that we have achieved to clinical data set. That is the real data set we have used here. No synthetic data set is used. This is the introduction.
Show the literature survey. Is it not visible?
I'm really sorry, sir. I don't know why is it.
You must take care of that. Just show me the result.
Yeah.
Literature review. I'm unable to read actually.
Okay. In the mobile, it was actually very visible. I don't know why. What happened here?
You are using the multiple color. That's why actually.
Might be.
Really
sorry. Really
the
sorry.
background should be light and text should be bold.
Yeah, I was more concerned about the.
That's why I really interested to know that.
Yeah, really. This was a very good slide.
Show me the reference list.
Yeah. Okay. 1 second. It is in the second last slide.
How many papers have you taken?
16 papers, sir. 16.
2026. How many papers have you taken?
We have used 2025, 2026. So total 4 of 2025.
How many 2026 blogs?
We have mostly, if I see.
I just want to know count. Because it's your paper, that's why.
Yeah, correct. So 2025 is the most recent one we have gone through, not 2026, because we were working this in the last year when we were in our second year. Yeah.
But actually we should
take care of
the background color.
Really very sorry. So it was actually visible in the phone, but
if we wear black pant with black shirt, 1,000 people will see.
I get it. Yes.
But if you are wearing right now, only 10 people will see, but they will admire the nice matching.
Thank you so much.
Have you understood?
I got it, sir. I got it with the example and I got the concept as well.
Written remarks you have understood.
Yes.
You didn't come earlier, I think. You should have checked actually over there.
No, in the phone, iPad, laptops.
Actually, this is very light. You can
it is also not.
Your friend has shown.
Yes.
So please take due care. It's a suggestion.
Yeah. I get it, sir. I'm not at all disturbed or anything like that.
Come to problem statement.
Yes. Problem statement. We go. The actually introduction. What was actually I was talking about the stroke. What is actually stroke? Then we will go ahead. So stroke is something. If I go with a very basic definition, the blood supply from the heart to the brain gets stopped immediately due to some reason. That is stroke, which is basically you don't have much time there. It will just lead to death. So early detection is the goal here. Now, I already told you it is a neurological disease and all that is written there. The global impact also we have discussed when I was in the addressing. Yeah. Sorry for this again. The research gap, yes. The limitations that we have found from the 2025-16 research papers that we have referred to are they using the synthetic data that the data is generated, which is actually fake, not real time, which is actually putting forward in large number of accuracy rate, but not giving us a real-time return in terms of accuracy. Now we have the synthetic oversampling that I've talked about. We also have the small single slide data set that the other research papers have been using. We also have poor real-time. So that is what I've summarized. Objectives. The to-do list of our research work, or what is our vision, that what are we trying to convey? We trying to implement a cost-sensitive machine learning framework. When I say cost-sensitive, it should run in every clinic. It should run run with the every doctor, so that is not very difficult to actually get predictions, get the reading, get the decisions. It is actually very easy and very cost effective to maintain data integrity. When I say data integrity, we are actually using the
take care of your time. You are allotted only 10 minutes.
Yes, sir. Yes, sir. Yes,
You are still at the objectives.
Yeah.
You have to proceed fast.
Yes. To develop a class-weighted machine learning framework, yes, we have already talked. This is a weighted learning. So, according to the weight, the machine is learning. Now, the methodology here. We used the Kaggle data set, of course.
Have you built Civil by yourself?
No, sir. I'll be honest. This is AI generated.
ChatGPT.
Yeah, Gemini I have used. But I was more concerned about how visually I can present it to you so that you can actually picture and analyze. Yeah. Thank you so much, sir. Thank you so much. Really glad. So layer 1, we have Kaggle Stroke dataset. What is the dataset conditioning? Like gender, age. These are all the features, sir. These are basically the features that we have in the dataset. Then there's a layer 2 where we have median missing values, categorical encoding, and we also have the stratified split. The split is 80-20 ratio, where if the total is 5,110, then 80-20 comes around 4,022 with 1,088 split. So the training data is basically around 4,022 and the testing data is 1,088. So layer 3 is the corresponding where we do with this feature distribution, class understanding, and also risk factor. Risk factor, why? Because we are using the real-time data which has noise inside it, which can actually, do a negative impact in the decision making.
Again, I'm asking, are you sure? Is it your image for your proposed one?
Yes, sir.
The layer 5,
Layer 5, yes.
If you monitor over there, logistic, CN3, random forest, and support vector, all 5 methods have been implemented in your single paper?
Yes. 4 methods we have implemented, 4 models. Yes, we have implemented. I also have the bar graph to show you that how are they performing.
Come to that.
Yes, this is the slide.
Sir, just a gentle reminder that 8 minutes are already passed.
I only have 2 minutes? Okay, I'll buckle up. So this is the, I'm again sorry with the color there. These are the comparison charts. The leading here is the random rainforest because we want multiple decision making here. A lot of features involved. For each feature, there is a vote. According to the vote, the random forest decided a proper decision. So that's why the random forest is leading over here. This is the result visualization. All the features that are equally important are arranged in the order along with the data visualization that I told you, 80-20 split, along with the ROC curve. And over there we have the confusion matrix.
Platform you have used for obtaining these results?
We have used Google Colab as well as Kaggle. So we have.
What are the important features of Google Colab?
So Google
Colab use these results.
So Google Colab, we can actually together we can bring the data to the entire pre-processing what we want to do. We can even invite teams there. Like I myself am there. I have 2-3 people. I can work together with them. Do all the necessary data splitting. Even I can label the data, train the model. Once I have trained the model, I can even check the accuracy, what is there, how it is behaving around the time. All these actions and these things are possible on the Google Colab platform.
Acha, do you understand the full form of GUI?
Graphical user interface. Yes.
So is it available in Google Colab?
Yes, sir. It is available.
It has to be.
It has to be because without that we cannot do it.
You cannot do it.
I was actually confused. You asked me the very basics of the Colab, so I was like, yeah.
We want to check whether the foots are on the ground
Absolutely.
or in the air.
Absolutely, sir. Absolutely. Yes.
Thank you.
Sir, I would like to show you something. We have our 15 minutes.
No, one more minute.
One more.
Thank you so much. Thank you so much. I would like to show you something about our work and all, so that we have the iPad and with their like Google Colab, we have actually stratified everything a structured format. He is my teammate Aditya Thokal. So
from where you me?
Sorry, I'm from Mumbai. And my name is Anish. He is Aditya.
What are you doing over there?
I'm doing data engineering along with machine learning.
Yeah.
Yes, sir.
Next for GPT center. Now I would like to invite Mr. Alay Sharma. The title of his paper is AI Driven Adaptive Intrusion Prevention using Honeypot Derived Feedback Loops.
यही तो बोलना था. You can create the data accordingly, you will get the results. And best optimized results you will take out of it. बस यही बात है. ठीक है. आपने बहुत पहले optimize किया मतलब कि आपको work की इसलिए तो मैंने GUI पूछा ना.
Take care of your validation skill. Do not use multiple colors.
Really sorry for that, but yeah, it was very nice. It was very close. And how would I help you? But because of you people being very friendly.
नहीं, the session should be interactive on both sides. Otherwise, thank you.
Hello everyone, I am Alay Sharma. I'm from Gangotti's University. I just graduated. So our work basically focuses on the very practical issue which everyone faces in the AI-based intrusion prevention system, which is false positive rates. So these are the outlines as per the abstract. So the existing work in this domain. The existing work in this domain actually gives a really good accuracy scores and good results on the paper. Like the paper has a very good results, but the biggest issues they face is on the real world deployment phase. So basically, our approach is just to do. So our work is basically a dual machine-based architecture. We have proposed an architecture. We have got these results over 9 lakh flows. Then so as you all know that in cybersecurity, the biggest issues if you are in a healthcare system or in some sort of big companies, the biggest issues you may face is false positive, because even a small false positive number can actually block legitimate users, which can even hamper your growth or your company's growth, right? So what our work is basically is to only reduce that false positive number. The literature review, we as we saw in other papers, that all the other papers basically focus on either increasing the accuracy or the recall or all those parts. They just focus on the numbers. They didn't give proper focus to the false positive rates or the real world deployment phase. So these are the different type of studies which happen, like signature based IPS also already exist. LLM based users, like some people did on research on LLM based users. Then they also use transformers, and they some of them also use honeypot integration, as we also used.
It's not a good way to represent as a literature review. Actually, you should mention the citation number or any paper number or paper name actually, from where you got this, like signature based IPS, which year it was published, where from you got this gap or summary kind of. You should have prepared. Have you prepared any in your paper also?
Like I have prepared in the references. I have given everything. I will show
Okay, move to the problem statement. What is your problem?
So basically, the research gap was very simple, that high accuracy alone does not make anything. Low positive, false positive is also required for the real world deployment phases, right? And the basic policy was also really addressed. High-model intelligence is actually used in the papers as we read, but they were actually used after the any sort of certain like attack has happened. After that, they were used. So we just integrated all of that. Our objective was to just reduce the false positive rates, increase the recall if possible, and give a proper stage-based deployment, because till now no one has done a stage-based deployment or a rollback sort of mechanism, right? If a new rule is generated and is implemented and it actually blocks some legitimate user, what then? So in our method, we actually included the verification stage, the validation stage. It helped us see if the result is not good, if the generated rule is actually blocking the legitimate users, it just rolls back to the previous version. So our methodology is just a dual machine architecture. We have tri-state decision scores, block, trap, and allow. Ensemblement, we use an ensemble model of RF, IF, and XGBoost. We use these 8 universal features, 8 conditions. So these were the results which we saw. So yeah, we also used the data sets of NSL, KDD, UNSW, and CEC, because these were the most prominent data sets for the networks. And these are the results. Overall, the results were overall accuracy was 97%. The ROC score was 90.99. And the latency score 0.014 millisecond. It's on a batched version. Overall of 71,000, nearly 71,000 flows per second. These are also the results and the false positive, false negative index metrics. So we also did, as I've said, in real world or in the deployed version, no one has properly done it. So we did try to use the whole architecture in a real simulated environment. So we tried these 7 attacks. As you see, the 2 attacks, they actually didn't pass, and that's why we figure out that this can be a future optimization, because these SYN flood attacks and the SSL brute force attacks, these are the rapid generational flows, right? So in this, they are basically, our architecture is just accepting or allowing the first network request. So it's a sort of a future optimization thing.
What is the full form of ICMP?
ICMP,
it's a full form of ICMP.
It's
But I'm asking the full name.
Okay.
I stand for what, C stand for what, M stand for what, and P stand for what. Because it is in your real section, isn't it?
You should know the full form, because the confidence with which you are speaking.
It's a very important part.
It's a mailing protocol that.
M stand for the message. I'm giving you a clue. It's a very important part. It is in your real section. Okay, no issue.
So the conclusion was these were the conclusions that in the SYN base and the SSS course they actually passed, but rest the results were nice. But in one thing, just one more thing, that in SYN-based attacks or the ports can basically, the ports can also fail just because it has a very less number of features in the request, right? So our model, our architecture could not properly identify whether it is a proper block or proper allow. So it just gave it to the validation phase or honeypot. So in the honeypot, it actually validated and allowed. That was just our basic request. These are the references. And sir, yes, sir.
Okay, thank you.
Thank you.
ICMP stands for Internet Control Message Protocol. It's a pop-up message. Speak command be used. Check that. Okay, thank you.
Thank you. But you should take care in your slides. The important part, all of you missed. The highlighting part, you should mention what you have done.
Presentation is a skill.
Actually, a flow diagram and flow chart is very necessary. Because when you show the flow diagram of flow chart, audience automatically gets the hint what you have done. So the probabilities of generation of query is minimum. Otherwise, you are forcing the audience to ask you more questions. You will be in more trouble. Take care of next time. Thank you.
Next one.
So with this, we successfully conclude the paper presentation session. Now I request our honorable guest to kindly come forward for the certification distribution ceremony. Sir, please come forward. Thank you, ma'am. Now I request Ms. Vinita Srivastav to kindly come forward and receive the certificate. Thank you, ma'am. Now I request Mr. Anish Mahesh Sangar to kindly come forward and receive the certificate.
From Bombay, you are from which college? University. So give universal understanding to the audience.
Thank you so much. Now I request Mr. Alay Sharma to kindly come forward and receive the certificate.
What is full form of DDL? सबको पता हो? नहीं. फिर कोई दिक्कत नहीं. You are afraid of full forms.
Thank you so much. Congratulations to all the presenters for their valuable research contributions. Now I request our guests to kindly remain on stage for the presentation of memento and certificates. To begin with, I request our respected Dr. Sheetal Gupta ma'am to kindly present the memento and certificate to Professor M.B.S. Chawla sir as a token of heartfelt respect and gratitude.
Thank you so much, sir.
Please give a huge round of applause. Thank you so much, sir. Now,
suppose I try to make the session live.
Now I again request Dr. Sheetal Gupta ma'am to kindly present the memento and certificate to Dr. Sandeep Sahu sir as a token of gratitude and respect.
Madam.
In case of PhD, right now, मैं rest
Thank you so much, sir. Now I request Dr. Sheetal Gupta ma'am to kindly come forward and deliver vote of thanks.
So thank you. Now it's my privilege to give the vote of thanks, Dr. M.B.S. Chawla sir and Dr. Sandeep Sahu sir. Sir, it was immense pleasure. Because the guidance you have given to the student, it was really valuable, and I think this was the lifelong learning for them. Thank you for your valuable time and expertise you shared with the participants. Thank you all the participants, faculty members, those who are present here and listening the sessions patiently. And I would also like to thank IEEE MP section to funding this international conference. I would like to thank management BGI to provide the platform conducting this conference. So thank you all once again. Now the participants can go for the lunch in room number 323.
automates payment through smart contracts. Here, what it basically covers, tamper-proof means that we are using the ledgers here, which cannot be contaminated in between, and the automate payments through smart